So in this lecture, we will see about the chi-square test. Probably this is the last major portion left in biostatistics. So in this lecture, I will be very briefly summarizing the whole of the biostatistics that we have seen till now. So the chi-square test is simplest and most widely used non-parametric test in statistical work. So this is the major non-parametric test, and it was discovered by Karl Pearson. Then what is parametric and non-parametric test? So about this I have already discussed in the previous lectures, but just to summarize it, the Z test and T test of significance are parametric test. Why these are parametric test? Because they are used for quantitative variables and are based on the assumptions of parameters of the variables. So I had already told you the parametric tests are always based on the parameters of variable, and non-parametric tests they don't need parameters of the variable. So the tests don't rely on assumption about population parameter. They are called as non-parametric tests. What are the population parameters? That is population mean and population standard deviation. This I have already discussed in the previous lectures. Now, what statistics is? It is classified into two parts. What are those two parts? Descriptive and inferential. Now, descriptive statistics include? It includes collection of data, organization of data, then summarization of data, and lastly presentation of data. Presentation of the summarized data. Whereas inferential statistics deals with the making of inference, hypothesis testing, determination of a relationship as we have seen in correlation and regression, then making prediction in regression, and hypothesis testing. Already just we have finished the hypothesis testing, and here also in this chi-square test also we will test the hypothesis. So in inferential statistics today I will be discussing about the chi-square test. Now in statistics we know that we are subjecting data to statistical analysis, and then based on the result obtained by statistical analysis we are making our decision. So here we will see about the data. Just we will remember, or we will just refresh what data is and how many types of data is. We have already seen in the initial lectures about the different types of data. So here you can see the data are of two types: quantitative and qualitative. Quantitative data, you know, it is discrete and continuous. In continuous, we have seen the continuous data may be of interval type or ratio type. So today our focus is not this. But our focus is on qualitative data. Qualitative data are of two types: nominal and ordinal. Nominal data and ordinal data. So chi-square test generally deals with the qualitative data, which may be either nominal or ordinal. And I hope you are remembering what are the nominal and ordinal data. So now qualitative data, it includes qualitative variable. Example is the gender of animal. The animal may be male or female. Frequency in that category. Suppose you are having 100 animal and 100 animals calved. So either there will be two type of calf that will be produced, male or female. So frequency of male. So 100 calves maybe 50 male, 50 female. So that frequency in a particular category is known as qualitative data. Nominal or ordinal scale, this I will not discuss it because I have already discussed when I was telling about the different types of data. Just you remember that, do you have a disease? The answer of this question, do you have a disease? The answer of this question will be nominal, yes or no. And what is the socio-economic status? Socio-economic status. The answer of this question will be the ordinal data. Answer. What will be the answer of this question? What is the socio-economic status? The status may be very poor, poor, rich, very rich. So this ordered data is called as ordinal data. Now, Karl Pearson, in his famous paper on ChiSquare, it was appeared in the year 1900, and it was thought that it is the auspicious beginning of a wonderful century in the field of statistics. At that time, there was no any other non-parametric test, and their work was published in Philosophical magazine. This is just for information, nothing to do with our course. You should know, and further you can explore how he discovered the ChiSquare test. Then what is the definition of ChiSquare test? So the ChiSquare, what is definition of ChiSquare? It is sum of a square of independent and normally distributed variable with zero mean and unit variance. So this is the definition of ChiSquare. ChiSquare is sum of squares of independent normally distributed variables with zero mean and unit variance. So here you can see chi-square can be represented as summation of x minus mu, that is sample mean minus population mean, divided by standard deviation, the whole square. So this is the definition for chi-square, and our whole of the analysis will roam around this definition and formula. So the next question is why chi-square? Why chi-square? So some of the idea I have already discussed. Here we will see systematically why we need chi-square test. So it is required to determine whether there is significant difference between observed and expected frequency. So I was talking about the frequency. Here you can see you have to test. Sometime you have to test whether there is difference between observed and expected frequency. Just remember a simple example. The 100 cow you are having, and that 100 cow undergo calving, and now you are having 100 calves. 100 calves you are having. The sex of calf. So if you see, the expected frequency of sex of calf should be 50 male and 50 female. But you observed that there is 40 male and 60 female. So now you have to test whether this deviation, your expected was 50-50, but you got 40-60. So now you have to test whether this deviation is significant or not. Whether this deviation is significant or not. So that will be tested by chi-square test. It tests the null hypothesis, stating that frequency distribution of certain event observed in a sample is consistent with the particular theoretical distribution. Now you know some of the theoretical distribution. Just similar to earlier one. Earlier one, you know, the ratio of male and female will be 1:1, that is 50-50. Now you want to test whether your observed distribution is similar to theoretical distribution or not. Similarly, suppose in the next unit you may be learning about the Mendel's law, or you have already learned in your +2 classes. So at that time you might, if you are remembering, you see the F2 phenotypic ratio in a dihybrid experiment. If you remember, F2 phenotypic ratio in a dihybrid experiment, the ratio will be 9:3:3:1. So you did an experiment, dihybrid experiment, and you got some observation. Now you want to test whether your observation is in that ratio 9:3:3:1, or there is some deviation. And if you are getting deviation, whether those deviations are significant or not. So that will be tested by chi-square test. The third case, the event considered must be mutually exclusive and have the total probability of 1. So whatever events, that is very important, you have to consider the mutually exclusive event only for chi-square test. Chi-square test will be done for mutually exclusive event and for which the total probability will be equal to 1. Now just see the chi-square distribution properties of chi-square distribution. So we have seen the properties of T distribution, properties of F distribution, properties of Z distribution, properties of normal distribution, Poisson distribution and binomial distribution. So similarly, this is here I have listed the properties of chi-square distribution. So chi-square distribution is positively skewed. It is positively skewed. You can see this is the positively skewed distribution and it extends from 0 to positive infinity. So here you can see it extends from 0 to positive infinity. That means you have to remember that value of chi-square will always be positive. It is starting from 0 to positive infinity. The standard deviation increases as degree of freedom increases. So in this case, as the standard deviation increases, standard deviation of the population or sample that you are having, if it is getting increased, your degree of freedom will also increase, and in that case chi-square will be spread more and more. It will be spreading like normal distribution. Just in the next slide we will see how it will behave with respect to degree of freedom. So similar to T distribution, as degree of freedom become very large, the shape become more like normal distribution. So if you remember the properties of T distribution, there also I have told you that as the degree of freedom increases, T distribution become the normal distribution. So here also it is telling that as degree of freedom increases, and when degree of freedom is increasing, when your standard deviation is getting increased. So as degree of freedom increases, your chi-square distribution will become normal distribution. Just see how it is behaving with respect to degree of freedom. So you just see as degree of freedom 1 was 1, it was skewed, and then degree of freedom 4, it spreads, and if degree of freedom is 20, it is getting spread and it is getting the shape of normal distribution. So this is how what the chi-square property distribution wants to convey. Now chi-square distribution is non-negative. We have already discussed because it is so because chi-square is a ratio of two non-negative values. So it is chi-square is always a ratio of two non-negative values. Chi-square is non-symmetric. We have already seen that it is skewed towards left. The mean of chi-square distribution is equal to the number of degree of freedom. So this is important to remember. The mean of chi-square distribution is equal to the number of degree of freedom. So as degree of freedom increases, its mean also get increased. The variance of chi-square distribution is twice the degree of freedom. So these are the points that we have to remember. The variance of degree of freedom is twice of the degree of freedom. Variance is twice of the degree of freedom. Now another one. The chi-square distribution is positively skewed. We have already discussed. It is extending from 0 to infinity. The standard deviation increases. Okay, this already I have discussed. Sorry. Now, what are the conditions for chi-square test? So here, there should be two or more categories. Whenever you are applying chi-square, you should have either two or more categories. Just see the example of the number of calves. So there you can see the calf birth. There you can see we were having two categories. First category was male, second category was female. In case of example of Mendel's dihybrid ratio, the class were 9:3:3:1. So total 4 phenotypic classes. So it should have two or more categories. Then observations should be independent of each other. So there should not be any relation with the observation. That is, it should have mutually exclusive. Observations should be mutually exclusive, that we have already discussed. Now sample size should be sufficiently large. It is always desirable that your sample size should be large, that is n should be greater than or equal to 50. Then no theoretical cell frequency should be less than 5. Should be less than 5 it is. Okay. It should not be less than 5. It should be greater than 5. So cell frequency, that is, suppose you are having calf birth and you are having two cell, male and female. So in male or female, the frequency should not be less than 5. That is the condition for chi-square. Then constant on cell frequency should be linear. So this is cell frequency should be linear. This just forget it. This is not required for your level. So it is always assumed that frequency of observed, summation of frequency of observed should be equal to summation of frequency of expected. So expected frequency and observed frequency should be equal. Now what are the steps that is involved in chi-square test? So first of all, you have to define the null and alternate hypothesis, as we are doing in every case. Then you have to tell the level of significance, the procedure of testing of hypothesis, calculate the degree of freedom, then state the decision rule. Decision rule means how you will reject and accept the hypothesis. Then you have to calculate the test statistics, and after getting the result of test, you have to interpret the results. So now this is the formula for chi-square. So what is the formula? Chi-square is equal to summation, this is the whole summation of observed minus expected square divided by expected. So this is the formula for chi-square. O is the observed frequency and E is the expected frequency. So this formula you have to remember. We have to apply this formula in the next in the examples when we will solve. So now how to find the expected value? Here you can see the observed frequency. Observed you will observe, so that you will have. But how to find the expected value? So for that expected value, if you are dealing with the chi-square, there are two conditions. First is the goodness of fit. When you are doing chi-square test for goodness of fit, then the expected value you can get from a theory or from a previous study or from comparison of groups. So what is the chi-square for goodness of fit? That we will see in the next coming slides. So here you have to remember that when you are testing for goodness of fit, then expected value you will get from a theory or a previous study or comparison of groups. Now when you are testing the independence of variables, chi-square test for independence of variables, then expected frequency will be equal to row total into column total divided by table total. So how it will be calculated, I will be telling you in the next part when I will be dealing the chi-square test for independence of variables. So here you have to remember, when it is chi-square for goodness of fit, there the expected value comes from a theory or previous study or comparison of groups. And if we are going for testing of independence of variable, then this is the formula by which you will get the expected value. Now state what will be the interpretation of the result, how you will what rules you will apply for interpretation of result. So you have to see whether the value of chi-square is more than or less than the critical value, as we are seeing in every case. If the value of chi-square is less, then you have to accept the null hypothesis. If it is more, then you have to reject the null hypothesis and accept the alternate hypothesis. Now first one is the chi-square test for goodness of fit. So here in goodness of fit, what we are understanding with the goodness of fit, you have to ask question: how close are the observed value to those which would be expected in the study? So just you have to see the closeness of observed value from the expected value. So chi-square of goodness of fit, expected frequency we have already seen, no need to worry. Now a goodness of fit test is an inferential procedure. It is an inferential procedure used to determine whether a frequency distribution follow a column distribution. That means the goodness of fit means you have to just find an understanding, or you can say that cohesion between the observed and expected. You have to test whether the thing that you are expecting is similar or not. The observation that you were expecting is similar or not, or if it is dissimilar, whether it is significant dissimilarity or non-significant dissimilarity. If a test of agreement or conformity between the observed frequency and expected frequency for several class or categories. So with one example we will understand it. So what are the steps? How to apply the test statistics in reality? When you will get the question, you have to do what you have to do. First, you have to prepare a table. So you have to prepare a 6-column table. I will just tell you the sample of the table. So you have to prepare 6-column table, and rows will be depending on the class. So if you are having 2 class, you have to form 2 row. If you are having 3 class, you have to form 3 row. Now write the heading of the first column based on the category of data used for test. So first column will be for category. Write the observed frequency in the second column and designate it as O. So in the second column you have to write the observed frequency, and heading of the column will be O. Then third, figure the expected frequency and write them in the third column named E. So third column will be for expected frequency. So you have defined here three column. First is the first column for category, second column for observed frequency, and third column for expected frequency. Just see the sample of the table. So here you can see the first column for category, second column for observed frequency, third column for expected frequency. Now you have to go for chi-square value calculation. So for that, this next 3 column will be useful. So calculate the chi-square by first obtaining the difference between observed and expected frequency. So this is how we are getting the, in fourth column we will get the observed and expected frequency difference. Then square of these differences in the fifth column. So in fifth column we have squared these differences, and in sixth column you have to divide the square of observed and expected frequency with the expected frequency of that particular class. And if you will sum it for all the categories, then you will get the chi-square value. Okay, I hope you understood that. Now after that, after getting the calculation of chi-square value, you have to compare it with the critical value or table value. So for that you have to see the chi-square table. But what will be the degree of freedom? At what degree of freedom we will see the table? So degree of freedom will be k minus 1. So what is k? K is the number of class. So if in case of male and female you are having only 2 class, so degree of freedom will be 1. So here you can see the chi-square distribution table. So this side it is degree of freedom, this side it is degree of freedom, and this side value at various level of significance. Values at various level of significance. So here you can see at 2 degree of freedom the value at 5% level is 5.99. So now if you will see one example, then it will be more clear to you. Suppose you are having a herd of Kankaraj cattle having 80 male and 120 female calves which were born during the year. Now you have to test whether the ratio of male and female is as of the expected one. So what will be the expected ratio of male and female? So we know from the observation and from our experience from the past history, we know that male and female expected ratio is 1:1. So
we will test whether this one in the farm, in the given farm, this 1:1 ratio is being followed or not. So for that you have to test by chi-square test. So you prepare this 6 column table. Here I have prepared 5 column table. One column has been skipped. So you see what are the columns that I have kept here. The first is the sex of calf, then observed frequency, expected frequency, observed minus expected frequency, and the formula of chi-square, that is observed minus expected square divided by expected. So in the sex of calf is male, observed was 80, and what will be the expected? So total calves are 200. So their your expected frequency will be 100 male and 100 female. So expected frequency is 100 for male, and difference will be minus 20, and then you have to square the difference. So square of the difference will be 20 into 20, 400 divided by expected one. So 400 divided by 100, that is 4. Similarly, for female, observed is 120, expected will be 100, and the difference will be plus 20. Now you square the 20, so it will be around it will be 400 divided by 100. So again 4. So total chi-square, because chi-square is the summation of this formula, so summation will come around 8. It will be coming 8. Now you have to test this whether your calculated chi-square is greater than or lesser than the tabulated chi-square value. So the calculated value of chi-square is compared with table value for 1 degree of freedom. Why 1 degree of freedom? Because degree of freedom here in this case, or in case of chi-square, will be k minus 1, that is number of class minus 1. So here number of class are 2. Which are those two classes? Male and female, sex of the calves. So the degree of freedom will be 1, and the value of chi-square at 1 degree of freedom at 5% level of significance is 3.84. So your calculated value is greater than tabulated value. Calculated value is greater than tabulated value. That is why you will reject the null hypothesis. And you see here, as earlier we have seen, this is the rejection region. So your calculated value is falling in this area. So you will be rejecting the null hypothesis. Now come to the another point. Another example we will see. So just see the example of SIDS. SIDS is the sudden infant death syndrome. So our assumption or question that is being asked in this problem is that each sudden infant death syndrome is seasonal. Whether a season is having any impact on this particular disease, or there is no effect of season. So just see, null hypothesis is telling what? The proportion of the deaths due to SIDS in winter, summer, autumn, spring is equal. So there are 4 seasons: winter, summer, autumn and spring, and the probability in each season, it is telling that it is 25%, or it is equal 1/4. So that is null hypothesis. And alternate hypothesis is telling that probability in all the seasons is not same. That means not all probability stated in null hypothesis is correct. So this is the alternate null hypothesis and alternate hypothesis. Now this is the observed frequency. This is the observed frequency. Here you can see in summer it is 78, spring 71, autumn 87, winter 86. Now total is 322. So 322 is the total frequency. Now you have to find out the expected frequency. What will be the expected frequency? Because total divided by 4, because there is 4 season, and expected, it is always expected that in all the season there will be equal frequency of that particular disease, or that is the incidence of SIDS, sudden infant death syndrome. So it has been calculated by 80.5. So 80.5 is the expected frequency. Now you are having observed frequency and expected frequency. So you are ready to calculate the chi-square value. So what we will do, we will calculate chi-square value, and the chi-square value, it is telling it is 7.81. How? No, sorry, it is telling critical value. So how you will calculate the chi-square value? Here you can see Here you can see the chi-square value 78 minus 80.5 is equal to how much it has been written, and that will be the difference will be squared and divided by expected. So here you can see this is the difference, and that has been squared and divided by the expected frequency. Similarly for second season, third season and fourth season, and finally you got the value of chi-square as 2.09. So here the question is, what will be the degree of freedom? So degree of freedom will be 3. Why it will be 3? Because there are 4 classes: summer, spring, autumn and winter. So degree of freedom will be k minus 1. So it will be 3. So at 3 degree of freedom, at 5% level of significance, the value of chi-square is 7.81. So your calculated value is lower than the tabulated value. So you will reject the you will accept the null hypothesis and you have to reject the alternate hypothesis. So what was your null hypothesis? That all the seasons are the incidence of seeds in all the seasons are equal. So here you can see conclusion: as calculated chi-square value is less than the critical value, we accept the null hypothesis. So we are accepting the null hypothesis, and state that after accepting null hypothesis, we are telling that death due to seeds across season are not statistically different from what is expected by chance. So if there is any difference, that is only because of chance. There is no actual difference exist. That means all the seasons are equal with respect to the incidence of seeds, that particular disease. Now you can see the next is the chi-square for independence of attributes. The next, first we have seen the chi-square for goodness of it. Another is for independence of attributes. So many a times we have information on 2 or more attribute on the same individual. So on same individual we are having information on 2 or more attributes. So it is used to find out whether there is an association between the row variable and column variable. So just once we will get the structure, how this example will come across you, then you will get idea what is row variable and column variable. So for getting association between row variable and column variable, we are preparing contingency table. So what is contingency table? That I will discuss in the next slide. Just see what are the assumptions. So before coming to the actual test statistics for independence of attributes, what will be the assumption? So here assumption is the variable should be independent. So variable should be independent. There also it was that variable should be independent. All expected frequency are greater than or equal to 1. So expected frequency should be always greater than, or at least it should be 1, not less than 1. Then another assumption is that no more than 20% of the expected frequency are less than 5. So you are not tolerating the expected frequency less than 5. And the formula is same as earlier. Chi-square is equal to summation observed minus expected square divided by expected. Now what you have to do, you have to go for, this is the contingency table that I was telling you earlier. What is the contingency table? Here this is 2 by 2 contingency table. 2 by 2 contingency table means there are 2 columns. This first column, second column, actual, and there will be 2 rows, first row and second row. So that is why it is called as 2 contingency table. So what type of question you will may be expecting in that, or what kind of situation you are expecting where you will have to test the independence of attribute. So the condition will be that somebody has developed a vaccine. Some vaccine company has developed a vaccine, and he want to test whether his vaccine is effective or not. So what they will do, they will just go for trial, and in that trial they observed that they vaccinated few people, they vaccinated a group of people, and there was control also. So they noted the observation. So they noted that in vaccinated group, a number of people were getting the disease and B number of people were not getting the disease. Similarly, in control group or the group who didn't get vaccine. So in such case where there is no vaccination, C were the people who got disease and D were the people who didn't get the disease. And we get the column total first A plus C, second column B plus D, and the row total A plus B, and second row total C plus D, and this is the total sum of all the frequencies. So this will be the your data structure. So whenever you are getting such type of problem, you should arrange your data in such contingency table, 2 by 2 contingency table, or depending on your classes. If there are more than 2 classes, vaccinated, non-vaccinated, and if there is another class, then you will have to go for 3 by 3 contingency table, or 4 by 4 or 5 by 5. Now you can present your data in this form also. The A plus B plus C, this is R1 is equal to row total, row 1 total, R2 is equal to row 2 total, C1 is equal to column 1 total, and C2 is equal to column 2 total, and N is the total number of observation. Now what will be your null hypothesis? So null hypothesis is that the vaccination and occurrence of disease are independent. That means there is no effect of vaccination on occurrence of disease, or the vaccine is not effective in controlling the occurrence of disease. Whereas alternate hypothesis is that vaccination and occurrence of disease are dependent. That means vaccination is affecting in controlling disease, controlling the occurrence of disease. So this is your hypothesis. Now you will have to test your hypothesis with the help of chi-square test. Just see, you have to find the expected. So here you get the in 2 by 2 contingency table, you got the observed value. Observed value, that was frequency A, B, C, D. So you got A, B, C, D are the observed frequency. Now you have to get the expected frequency. How you will get the expected frequency? EA, that means for class A, what was A? Vaccinated who got the disease, A. So expected, what will be expected? R1 C1 divided by N. Similarly, for B expectation, R1 C2 divided by N, C expectation, R2 C1 divided by N, and D expectation, R2 C2 divided by N. So now after obtaining the expected frequency, chi-square can be calculated by the formula that we already know. Now, there is one more method by which you directly get the value of chi-square. You don't have to separately calculate the expected frequency, because all the expectation in this formula, the expected value has been included. Indirectly you are calculating the expected value. So chi-square will be AD minus BC whole square into total number of observations divided by R1, R2, C1, C2. You know each and every term in this formula. You will get the directly you will get the value of chi-square, which will be compared with the table value. Now here you can see the shortcut of chi-square. So this is the shortcut, same thing. It has been presented in different notation in the form of A, B, C, D. It is not means R1 and R2 has been avoided here. So directly you can get the understanding of the notation, meaning of different notations. Now you can get the solution. So one example has been given here. So you have been exposed with certain virus or bacteria, and then the occurrence of disease. So whether if your exposure, you have been exposed and you got the disease. A group of animals have been exposed to particular causative agent, they got the disease, and another group is that they are exposed but they didn't get the disease. Another one is not exposed and got the disease, and next class is not exposed and didn't get the disease. So this is A, B, C, D. Now this is the A plus C and B plus D. Similarly, A plus B, C plus D. And this 120 is equal to N. Now you have to calculate the expected value. So expected value, you know how to calculate expected value. I have already told you about the formula. It is 50 by 120 into 54. Why it is 50 by 120? Because 50 is R1. R1 divided by 120. 120 is the N into 54. What is 54? It is C1. R1 C1 divided by N. So already I have discussed this formula. Based on that formula, you will get the expected value. These are the expected value. Now, after calculating expected value, you will put these values in the formula. So you here I have put it into the formula and got the value 29.1. Or else what you can do, you can directly put the value into the simpler formula. Here you don't have to calculate the expected value, simply put the values what it is telling, n ad minus bc. So like that, here also we are getting the calculated value as 29.1. now so in this way you have calculated the value of chi-square that you can compare with the table value. Now what are the limitations of chi-square test? So in this case, in which case, while testing the independence of attribute. So the limitation is that no expected frequency should be less than 2. It should not be less than 2. I have already told you that it should not be less than or it should be equal to or less more than 1. But it is desirable that it should not be less than 2. And also more than 20% of the cell should not have frequency less than 5. So these are the limitations for chi-square test of testing independence of attribute. So what will happen if these assumptions are not met? So there are provision if these two assumptions or the assumptions are not met. So there is one modification of chi-square test that is known as Fisher-Extrakt test. Fisher-Extrakt test. So just you remember the name Fisher-Extrakt test. This is not part of your syllabus. So here we will not discuss about the Fisher-Extrakt test. So in this way, I am finishing here the chi-square test. In case of any query, you can contact me. So thank you.